hazards like thermal explosions and earthquakes for Yellowstone National Park.
The calm dawn at Yellowstone shattered with a roar so deep it felt like the earth itself was growling. The sound rolled through pine forests, over steaming vents, and across frozen rivers. Campers woke in shock, thinking it was thunder, but the sky was perfectly clear. Within minutes, a cloud of dust rose, followed by a chilling column of steam twisting into the cold mountain air. Rangers rushed to guide frightened tourists as the ground pulsed beneath them. But this wasn't a normal quake. The blasts came short, violent and hollow, like muffled detonations from below. Geologists instantly knew what it meant: a sudden fracture deep underground, unleashing pressure through the superheated rock and water beneath Yellowstone's surface. For decades, the park has been a place where beauty hides danger. Beneath its meadows lurks a massive magma chamber, one of the most powerful volcanic systems on Earth. And on that morning, it reminded everyone that it's still alive. The blast was no ordinary tremor. It was the kind that made scientists question Yellowstone's stability. Emergency crews locked the park down within hours, sealing every entrance under flashing hazard lights. This wasn't just precaution, it was fear of what might come next. If pressure underground had shifted, more violent eruptions could strike without warning. At the blast site, a fresh vent gaped open, glowing faintly with heat. Steam hissed upward, carrying the sharp stench of sulfur, while trees around it stood charred black, stripped bare as if torched by fire. Snow melted into scorched soil, and even in the freezing cold, waves of heat shimmered through the air. The scene was eerie, like a wound torn straight into the earth. Seismologists confirmed microquakes had rattled the area just before the explosion, signs of pressure boiling over. The verdict? A hydrothermal explosion, where superheated water bursts into steam with deadly force. Normally small, this one was far larger, powerful enough to rewrite Yellowstone's underground map. The blast had the power to change everything, shifting geyser behavior, collapsing ground, and ripping open new vents where none had ever existed. What made this one terrifying was its depth, hinting at layers disturbingly close to Yellowstone's magma system. As news spread, social media lit up with shocking images: steam columns glowing faint red at their base, and shaky footage of a muffled roar unlike any geyser or vent eruption ever heard. Officials refused to link it to volcanic activity, but the scale spoke for itself. This was no routine incident. Shutting Yellowstone wasn't about safety drills or seasonal hazards, it was about raw uncertainty. Closing the park meant admitting the danger was real. Yellowstone isn't just a tourist paradise, it's a living laboratory, and sealing it off sent a chilling message. Something bigger might be unfolding. The blast also threatened the ecosystem. Plants and animals that rely on the park's geothermal warmth could face sudden upheaval, while shifts in water chemistry and habitat loss loomed. And geologists knew the stakes. Yellowstone's caldera was born from a supereruption. Every anomaly here is a warning sign. Even though the blast wasn't magma-driven, it exposed a chilling truth. Pressures deep inside Yellowstone might be shifting. If fractures had opened, they could create new channels for superheated fluids, fueling more violent activity above ground. Scientists scrambled, setting up gas monitors, ground sensors, and thermal cameras, while helicopters swept over an eerily silent park. Roads once packed with tourists now sat empty, turning Yellowstone into a locked-down exclusion zone. Witnesses recalled the shock vividly. Some felt the ground ripple beneath them, like standing on a ship in rough seas, while others heard popping and hissing from hot springs as if the earth itself was reacting. Pools turned cloudy within minutes, and geysers miles away erupted off-rhythm, their natural cycles thrown into chaos. The indefinite closure made one thing clear: no one knew the full scope of the disturbance. Unlike a wildfire you can see, a blast beneath rock and steam leaves almost no trace. The fact that such a massive explosion struck without warning was a stark reminder. Yellowstone's underground world is far more volatile than we understand. Yellowstone defies prediction. Superheated water can sit quietly for centuries before erupting in seconds, and magma can shift silently beneath the rock while the balance between calm and chaos changes without warning. That's why the closure carried such heavy weight. It wasn't just about safety, it was symbolic. Yellowstone is more than a park. It's an American icon, a living reminder that nature's power can't be tamed. For local communities, the shock was immediate. Tourism froze overnight, and residents were left asking, if this happened once, what comes next? Officials reassured that the threat didn't extend beyond the park, but fear still spread. The ground had just proven it could unleash fury without warning, and that knowledge alone shook people to their core. Meanwhile, the blast's legacy lingered. A ghostly column of steam twisted into the sky for days, visible for miles. It stood as a chilling reminder that the same forces that carved the mountains and valleys of the West are still alive beneath Yellowstone, restless, powerful, and unpredictable. The roar had faded, but the sight of that vent, spewing steam into the sky, was a chilling reminder that Yellowstone was still shifting below the surface. The blast had ended, but the forces that caused it were still alive, hidden in the dark. Yellowstone isn't frozen in time, it's a living machine, a thin crust covering a restless geothermal engine capable of life and destruction alike. And the line between the two is razor thin. As the park stayed sealed off, specialists from the Park Service, USGS, and the Yellowstone Volcano Observatory rushed in. Helicopters ferried equipment, careful not to fly directly over the new vent in case it triggered another blow. What they found was shocking. The blast zone stretched farther than expected. Scorched earth, fractured rock, and collapsed ground spreading across the landscape. Thermal cameras revealed not just one crater, but clusters of hidden hotspots. It wasn't a single rupture at all. It was a chain reaction, a network of underground fissures ripped open like torn arteries, venting their scalding fury into the frozen air. The blast revealed just how violent Yellowstone's hidden power can be. Hydrothermal explosions are usually small and contained, but this one hurled debris far beyond the crater, littering slopes with scorched rock and carving trenches through snow and soil. Some fragments showed chemical scarring, etched by scalding steam and water in a matter of seconds. Geochemists in protective suits moved in, scraping hardened mineral crusts and sampling steaming ridges. Their mission: find out if this blast had tapped deeper reservoirs closer to Yellowstone's magma system. If so, it wouldn't just be surface drama, it could signal a shift far below. Meanwhile, the park grew unnervingly still. Snow buried empty roads, elk and bison roamed freely, and without tourists, the land felt ancient, raw, almost prehistoric. Rangers noted geysers outside the blast zone erupting strangely out of sync, another hint that the underground shock had rattled Yellowstone's delicate balance. And one burning question drove the entire investigation. What triggered the buildup of pressure powerful enough to tear the earth open like this? Yellowstone's hydrothermal system survives on a razor-thin balance of heat, water, and pressure. And when that balance breaks, chaos follows. Seismic data showed a rapid chain of microfractures opening pathways for water to plunge deep into hotter rock. Superheated past its boiling point, it flashed into steam and exploded with brutal force, ripping soil and stone apart. But the sheer depth of this blast raised bigger questions. Some scientists suspected subtle magma movement might have added extra heat, priming the system for violence. If true, even small disturbances could now trigger more deadly eruptions, making non-stop monitoring essential. Hydrologists joined the effort too, tracking how the blast might have twisted Yellowstone's plumbing. A collapse underground could shift geyser cycles, change water chemistry, and ripple through the entire ecosystem, affecting plants, insects, migrating animals, even rivers carrying altered minerals far downstream. In Yellowstone's past, prehistoric blasts carved massive craters that now look like calm ponds. The new vent wasn't as huge, but still ranked among the most powerful modern explosions on record. Scientists knew they were witnessing forces that have shaped this land for thousands of years. Gas monitors lit up after the blast, recording spikes of carbon dioxide and hydrogen sulfide. Normal for Yellowstone, but dangerous in high doses. These fumes can pool in low areas, threatening both animals and people. The data hinted at something deeper. The explosion had likely rerouted underground vents, changing how gases escape. That shift could alter the park's surface features, making some geysers rage harder while others fall silent. The event reignited a bigger problem. How do you monitor a beast this big? Yellowstone spans 3,500 square miles, much of it rugged wilderness only reachable on foot or by helicopter. Sensors and cameras help, but they can't catch every flicker of pressure or heat. The blast proved that even here, one of the most studied volcanic systems on Earth, disaster can strike without warning. The closure also sent shockwaves through nearby towns. Tourism collapsed overnight, hotels emptied, tours were canceled, shops shuttered. Beyond science and safety, it was clear. Yellowstone's health is tied to thousands of livelihoods, and one violent blast was enough to shake both the ground and the economy. With Yellowstone emptied of people, scientists suddenly had a rare gift, a chance to watch the geothermal system in its purest state. No cars shaking the ground, no tourists disturbing geyser pools, just raw nature breathing on its own. The data gathered here could set new baselines, making it easier to spot real warning signs in the future. Beneath the surface, though, the Earth was still shifting. Sensors picked up tremors, some from fractured rock settling near the vent, others hinting at deeper movement. The challenge? Yellowstone is never silent, so teasing out which quakes mattered was like trying to hear a whisper in a storm. Meanwhile, wildlife moved in as humans vanished. Wolves padded down empty roads, bears left tracks outside closed visitor centers. The park was already reclaiming itself. At the vent, drones and thermal cameras kept constant watch. Steam hissed with strange hues, colored by hidden minerals, each detail a clue to the forces still at work. For all the science, one feeling lingered most: humility before a power no one can control. For the scientists who've spent their lives studying Yellowstone, the blast was both a challenge and a chilling reminder. This land answers to forces far greater than us. Standing at the safe perimeter, watching that vent pour steam into the icy air, many felt the weight of geological time itself. Yellowstone isn't a museum. It's alive, restless, and always capable of sudden, violent change. The closure turned into a living case study. Every move, where to place sensors, how to warn the public, was shaped by the realization that stability here is fragile. The event also drew instant global attention. Experts from Iceland, Japan, New Zealand, and Italy, nations with their own fiery landscapes, contacted U.S. agencies within hours. Hydrothermal blasts of this scale are rare, and Yellowstone's unique system made it the ultimate natural laboratory. Using seismic scans and ground-penetrating radar, teams began mapping the fractures torn open beneath the park. What they'd uncover could change how we understand Yellowstone forever. And if you want to follow every twist of this story, don't forget to subscribe, like, share, and drop a comment. It keeps you in the loop when nature decides to shake things up. Seismic models revealed how the blast's shockwaves ripped through Yellowstone's rock layers, widening old fractures, opening new cracks, and sparking strange changes miles away. Some geysers grew wilder, while others went silent, proof that the explosion's force traveled unevenly through hidden fault lines. This selective energy spread showed scientists which zones might be most vulnerable to future chaos. One key suspect: supercritical fluids, water trapped under extreme heat and pressure until it behaves like both liquid and gas. These underground reservoirs can store massive energy, and when they suddenly depressurize, the result is explosive destruction. The Yellowstone blast carried all the signs of such a violent release, making it a crucial case study. To track what came next, satellites scanned the region with radar sensitive enough to detect shifts of just centimeters in the ground. Laser mapping teams captured every detail of the new crater, its jagged walls, debris fields, and steaming drainage scars. Together, the data painted a picture of an underground system still shifting, still restless, still alive. High-resolution scans let scientists measure exactly how much material the blast had hurled out, key clues to its force and depth. But the biggest shock came from airborne spectrometers. The steam plume carried rare elements not usually found in surface emissions. That meant the explosion had cracked into deeper rock layers, possibly opening new underground pathways for fluids to rise in the future. This discovery sparked global concern. Hydrothermal blasts, unlike volcanic eruptions, give little to no warning. Pressure builds and releases in seconds, too fast for alarms to save lives. Agencies worldwide, from New Zealand to Japan to Italy, suddenly re-examined safety around their own tourist-filled hot springs. Yellowstone had proved that danger exists even without magma rising. The event also caught the attention of geothermal engineers. The same conditions, superheated water, pressurized reservoirs, sudden release, mirror the very forces behind geothermal power plants. While technology keeps facilities safe, Yellowstone was a brutal reminder of just how much energy lies hidden beneath the crust, waiting for the smallest trigger to explode. The Yellowstone blast didn't just shake the ground, it shook how people see the park itself. To most, it's a place of waterfalls, geysers, and roaming wildlife. But the eruption of steam and force was a harsh reminder. All that beauty rests on a volatile foundation. Indigenous communities, whose oral traditions speak of the land breathing and the earth speaking, recognized it as part of nature's timeless rhythm. A reminder that Yellowstone is alive, powerful, and unpredictable. If you want to follow more stories like this, don't forget to subscribe, like, share, and drop a comment. It helps keep this journey going.